Hey everyone, welcome. Today we're jumping into a really cool and practical chapter, surface areas and volumes. We're surrounded by 3D shapes. Think about everything from toys to huge buildings. We're going to learn exactly how to measure them.
Okay, so to get us started, have a look at these two things. We've got a big tanker truck and a small test tube. At first glance, they look totally different, right? But if you put on your math goggles, what's the one big thing they actually have in common?
And that's the big secret. They're both made by combining simple 3D shapes. You remember these from class 9, right? The tanker is just a cylinder with two half spheres, or hemispheres, stuck on the ends. And the test tube? That's a cylinder with one hemisphere at the bottom. So this whole chapter is about figuring out the area and volume when we put these simple shapes together.
All right, let's kick things off with part 1, finding the surface area of these combined shapes. The easiest way to think about this is imagine you have to paint one of these objects. How would you know how much paint to buy? Well, that's what surface area tells us. So to really get this, let's build something simple together. Imagine we're making a toy top, a latu. All we need is a cone and a hemisphere that have the exact same circular base. Then we just stick them together. Okay, now here's the big question. This is a super common tricky spot, so pay close attention. If we want to find the total area we need to paint on this new toy, can we just find the total surface area of the cone, find the total surface area of the hemisphere, and just add them? What do you think? Yes or no? The answer is a big, loud no. And once you understand why, you've basically mastered the hardest part of surface area problems. Here's the thing. When we glue the cone and the hemisphere together, what happens to their circular bases? They disappear. They get stuck together on the inside of the toy. You can't see them, you can't touch them, so you're definitely not going to paint them, right? This is the key principle. For the surface area of a combined solid, we only care about the parts we can actually see and touch on the outside. Okay, theory's done. Let's try a real problem. This is a classic one. We've got Rashid's latu, his playing top, and it needs a coat of paint. It's made of a cone sitting on a hemisphere. We're told the total height is 5 centimeters, and the diameter is 3.5 centimeters. Our job is to find the total area he needs to color. All right, let's tackle this step by step. First things first, we need a game plan. So, what parts are we painting? Well, we're painting the curvy part of the hemisphere and the curvy part of a cone. So our formula is simple. Total area equals the curved surface area of the hemisphere plus the curved surface area of the cone. Let's start with the hemisphere. We know the formula for its curved surface area is 2 pi r squared. Now, they gave us the diameter, which is 3.5 centimeters. The radius, r, is always half of that, so it's 1.75 centimeters. Now we just plug that into our formula. 2 times 22/7 times 1.75 squared. Okay, hemisphere part is set up. Now for the cone. To find its area, we're going to need its height. So we know the total height of the toy is 5 centimeters. And think about the hemisphere part. Its height is just its radius, right? Which is 1.75 centimeters. So to get the height of just the cone, we take the total height and subtract the hemisphere's height. So 5 minus 1.75 gives us 3.25 centimeters for the cone's height. Great. Now we have the cone's height. But the formula for its curved area needs the slant height, L. Remember how to find that? Good old Pythagoras' theorem. The slant height L is just the square root of r squared plus h squared. So we plug in our numbers, the square root of 1.75 squared plus 3.25 squared. Do the math, and you get a slant height of about 3.7 centimeters. We are so close. You're doing great. Now that we have r and L, we can finally find the curved surface area of the cone. The formula is pi rl. So we just pop in the numbers. That's 22/7 times the radius, 1.75, times our new slant height, 3.7. Okay, this is it, the final step. Remember our plan from the beginning? We just need to add our two pieces together. We take the area we calculated for the hemisphere, and we add the area we just calculated for the cone. That's going to give us our grand total. And there it is. The final answer is 39.6 square centimeters. That's the total area Rashid has to paint. Awesome job, everyone. So, just to quickly recap, for any surface area problem like this, it's a simple 3-step process. 1. Figure out which surfaces are visible on the outside. 2. Find the area for each of those visible parts. And 3. Add them all up. That's it. And here is a huge exam tip. Please, please remember this. The number one mistake people make is they just add the total surface areas of the two shapes. Don't fall into that trap. Remember, the parts that are glued together are hidden. They don't count.
Fantastic. You've just nailed the hardest part of this chapter. So let's move on to part 2, which is volume of combined solids. And I've got some really good news for you. This is way, way easier.
So what's the difference? Well, for surface area, we had to be all careful and only add the outside parts. But for volume, forget all that. Volume is just about how much space is inside something. If you stick two containers together, the total space inside is just the sum of the two spaces, right? Nothing gets lost. So the logic is super simple. You just add the volumes of the individual shapes. That's it.
Let's see just how easy this is with an example. Check out this industrial shed. It's basically a rectangular box, a cuboid, with half a cylinder for a roof. Our mission is to find the total volume of air that can fit inside this shed.
And our plan this time? It's so straightforward. The total volume is just the volume of the cuboid part plus the volume of the half-cylinder part. No tricks, no thinking about what's hidden, we just add them. So let's crunch the numbers. First up, the cuboid. That's just length times breadth times height. We plug in the numbers and get our first value. Easy. Next, the half-cylinder on top. The formula for a full cylinder is pi r squared h, so for a half-cylinder, it's just half of that. We pop in the values for the radius and the length and calculate the second part. Now we just add those two results together and that's our answer. The total volume of air inside is 1128.75 cubic meters. See what I mean? So much simpler. Okay, so to wrap everything up, let's lock in the main idea. For surface area, the key word to remember is visible. You only add the areas you can see on the outside. But for volume, the key word is simple. You just add the volumes of all the individual parts. If you can remember that one crucial difference, this chapter is going to be a breeze for you. You did a great job today. Keep practicing, and I'll see you in the next one.